Hi, welcome to another episode of the Joyful Balance podcast. I'm here with my co-host Meera, and
Hi.
this time we are together. Woo! So if you're new, we are having a podcast about neuroscience, psychology, hypnotherapy, and good old living. All mixed into one. We also talk about nutrition, and we are here to just guide you on your journey. We are on our journey ourselves.
Absolutely.
And we are just sharing knowledge and trying to make it, less alone for you and helping to better your relationships with yourself, with others, and with food. So without further ado, here we are, another episode.
Another one.
Wow.
I know. How's it going?
Yeah. I don't really have an answer to that.
Yeah, you've been busy.
We've both been busy, guys, and we are currently in a studio, as you can see. If you can't see us, we are in a studio. We are doing this the professional way.
Yep.
And it's the first time either of us are in such a studio, so a little bit of, rookies here.
Yeah, there was a bit of a kerfuffle, but it's fine. We're learning as we go along. We'll make it bigger and better every single time.
Absolutely.
And I think I'm feeling more relaxed now. We're kind of ready and set, and
Yeah.
yeah.
Yes, so today it's all about the brain. I should have said that.
That is fine. Yeah, so today it's a lot on me, so I apologise in advance for how much you're going to hear me talk. So I'm going to be taking you on a tour of your brain, trying to give you the really interesting parts. And Denise, you're just going to pepper me with questions that I can hopefully answer. And then I'll tell you what's what. How does that sound?
Sounds good.
All
good.
right.
Let's go right into it.
All right,
so.
Cool. So essentially, I studied, just by background, I studied neuroscience as a master's, and then I ended up as a result of personal experience, which we've kind of covered in a previous podcast, finding that nutrition really helped my mental well-being, and wanted to find out more about nutrition and understand how it works from a neuroscience perspective. And so I went and pursued a whole other qualification in nutrition, and now I'm very, very lucky that I get to marry the two really nicely. But even though whenever I tell someone I have a degree in neuroscience, everyone always thinks my IQ points are like 12 points higher than they probably actually are. But no one really knows what it is. And so I thought I would actually start with a little explanation of what neuroscience actually is. So, as it says on the tin, it's basically the study of the nervous system, and it's kind of looking at how the nervous system is structured, because we always say in biology, the way things are structured ultimately tells you what it actually does. So it was drummed into me from a very young age, structure equals function, and that will always come up when I'm explaining how the brain works and how nutrition helps the brain and all that kind of stuff, because it's important. And we kind of study it all the way from development all the way to when it degenerates, sadly, in later life, or sometimes even along that journey. And so it's really understanding the brain, the nerve, how it links the spinal cord, all the nerves that come off it. But generally with a lot of neuroscience, there's a lot of emphasis on the brain, which arguably is actually one of our most undiscovered organs because it's so hard to test. And if I remember, I'll try and pepper in some interesting ways that they kind of test brain and all those exciting things, including in surgery, which is kind of an interesting point. So I'm going to just jump straight into it. So we always divide the nervous system into two. So you've got the central nervous system, which is your brain and your spinal cord, and we've got the peripheral nervous system. I'm going to part the peripheral bit aside because that's basically all the nerves that kind of, come off the spinal cord and affect your hands, exactly, your arms, all your organs. We'll talk a lot in probably this episode, but the next episode where I cover nutrition and the brain, how the gut and brain are very heavily interlinked. But we're going to part the peripheral nervous system because what I certainly focus on a lot is the central nervous system, particularly the brain. Now, your brain is made up of somewhere between 86 and 100 billion neurons. And only just ballpark. And there are about 5 times as many neural cells that basically help your nerve cells send electrical signals and chemical signals. So it's a massive, massive network of cells.
But tiny, right?
Oh, the cells themselves.
Yes. Because I'm just imagining our brains, they have, mass and everything, but they're not that big, so they can hold billions and billions of big cells.
But what's really interesting is, how much do you think a brain actually weighs?
Educated guess?
Go on.
400 grams.
So it weighs a whopping 1.5 kilos.
Woo!
Yeah, which is about 3 pounds. So, and a lot of that is because it's actually 60% fat.
Oh.
And so that's really important, because I'll go on in a later episode to tell you why fats are actually so important for your brain, particularly the right ones. Now, your brain is kind of divided in half. So you've got what's called the right and the left hemispheres. Now, what's really interesting about the way your brain works is that the left side of your brain controls the right side of your body, and the reverse is true. So what did I say? Right. So the left side of your brain controls the right side of your body. Right side of the brain controls the left, and it's called contralateral control. Now, we, as you know, when you study neuroscience, when you study any kind of biological sciences, right, we love to categorize and break things down and provide like 600 names for almost the same thing. So we've got the brain, and it's not only divided into two halves, you've also got what are called lobes. So they're sections of the brain.
Yep.
And so I'm purely, not expecting you to remember any of this. Even I sometimes forget this, and
we
this
will
is
give
my
you
brain.
a test, guys.
Oh
after
God,
this.
don't. It was a test of my memory, actually, to see how much I could remember. So we've got the frontal lobe, which is kind of the most interesting part for you and I, where it's basically all about sort of emotional regulation, controlling your impulses, decision making, a little bit of movement, which is something I'm going to come back to later. And even part of your speech is controlled in this area. And there's a very interesting patient that I'll come back to in relation to that. You've then got your parietal area, which is kind of along the sides. And that essentially is about object identification, understanding where you are positioned in relation to other things in your environment, which probably explains why my spatial recognition is dreadful. And also it's about sensation, so interpreting pain and touch. And there's also another part of actually speech recognition in that area. Now, you also have, your parietals are kind of more up here. You've got your temporals along the side, and that's more for memory. Again, a little bit of speech. Interestingly, recognizing smells and musical rhythms. So essentially, when you're enjoying a piece of music, whether that's classical or whatever you enjoy, that's the part of your brain that really, really lights up. And they can see that in studies. And interestingly, even though your eyes are obviously at the front, you interpret all of your vision all the way at the back in the occipital lobe. So you essentially, your what your eyes see has to travel actually quite far back into your brain for you to actually register what it is that you're seeing.
Hence, if you hit your head, you'll get the blurry vision for a little while.
Yeah, and people who have unfortunately sustained damage to the back of their head, can very easily lose their vision. So if we take aside the fact that you've got these two hemispheres, you've got all these four kind of different zones, if you like, what we're also really interested in is more the deeper structures, and these are particularly important, particularly when we think about things like memory and emotional processing, which are really relevant to a lot of what we talk about and what I'll certainly be referring back to all the time. So we've got this amazing tiny little gland that actually sits sort of deep behind the bridge of the nose. So actually, if they're operating on this part for whatever reason, they can go up into your nose and actually do whatever they need to do to that part of the brain, which is wild to me. And so essentially...
Sorry to interrupt you.
Yeah.
That reminds me of lobotomies.
Yeah, not so much a thing now.
I know, thank God.
Yeah.
No, I'm not vouching for them coming back, but I just remembered one of these scenes where they were, the lady suffered with melancholy or something stupid they used to call it, and then they were doing those kinds of things to regulate.
Yeah, thankfully the treatment of like mental health conditions has come a long, long way.
Oh,
and
thank God.
Yeah, it's still got a long way to go, but in terms of what we know about the brain and how it works, The types of medications they're now finding that works, the types of psychological therapies that they're finding work, means that, the lobotomies were basically useless.
They were.
Apart from,
they were.
Yeah.
They were. But that was just a side note in the sense that the gland that Meera was telling us about is positioned so, in a prime spot that somebody at some point thought it was a good.
Yeah, which is
idea.
crazy, because it actually it regulates the hormones in all parts of your body, which is why I'm mentioning it. So things like your thyroid, which are really important glands, particularly for metabolism and even for your mood, that kind of sit in your neck. Your adrenals, which are really important for your stress response, they sit above your kidneys, and also your sex organs as well, so the ovaries and the testicles. Now, what's also really important is what sits above the pituitary gland, and this is one of the most key emotional one of the key regulatory structures. So the pituitary gland then sends its chemical signals to what's called the hypothalamus, and that's really involved in your regulating your body temperatures, your sleep patterns, hunger and thirst, and also memory and emotion. And then now I'm getting to a couple of the really interesting ones, and these are my two faves. And that's the amygdala, which is this small almond-shaped structure.
That's my favorite.
Yeah. It's actually, it sort of sits underneath the two halves of the brain, and that regulates your emotions, your memory. It's also got a role in your reward system and massively in your stress, fight or flight response. And that's something that I will come to in a future episode. I promise I'm through the boring structures, but I wanted to kind of take you through a very brief tour just to get you to orient yourself towards the brain, what neuroscience is all about, what we know that the brain does, and also it will give you a reference point when we continue these episodes, and this will continually come up.
I think what I wanted to just pinpoint very quickly is this little almond-shaped gland in the huge place that is the brain, that Meera just told us it weighs over a kilo. She's tiny.
Yeah.
I call her she because women rule the world.
Absolutely.
So she's so tiny, and she has such an important role.
Yep.
Such an important.
And one of my other favourites that I almost equate equally is the hippocampus. So this is a really funny little seahorse-shaped organ, part of the brain structure that sits beneath each temporal lobe, kind of really in the middle, and that really supports your memory, your learning, navigation, perception of space, and that's also got a very heavy role, particularly with mental health. It's a lot of what we worry about in states, when we start to think about people, unfortunately, start to lose their memory in later life. So the hippocampus and amygdala, along with a few other structures like the thalamus, which is basically like your gateway of all the sensory information that comes into the brain and how it passes it all out. Other different structures whose names are really, really complicated and probably not that interesting. And also the frontal cortex. Together they all start to form what's called the limbic system, which is really important for emotional regulation. And that is something that we will come back to again and again and again. So now we've kind of got all the structures out the way. Now what's really interesting about humans and the human brain is that relative to our body size, our brains are actually quite big. Now they've looked at they've looked at different animals and tried to assess, actually, does that indicate that we are more how does that link to intelligence? Now, like many things, it's not a straight correlation and a direct relationship that guarantees that the size of your brain relative to body size indicates how intelligent you are. But generally, the trend says that the higher that ratio is, generally, the more intelligent that species actually is. But what's the reason that kind of we get that competitive edge over different animals in the animal kingdom is because we've got such a developed frontal cortex, which really enables us, it improves our intelligence vastly, and it also gives us the edge in terms of planning, which animals don't have quite as much of, and that really gives us a competitive advantage, and helps us be basically top of the animal kingdom. Now, the other things are that, even though the brain only makes up about 2% of body weight, it actually takes up a whopping 20% of energy, which is huge.
20%?
Yeah.
Wow.
Yeah. So your brain is an unbelievably energy hungry organ, and that's really important for us to bear in mind when we're starting to think about what nutrition we provide for the brain. It's unbelievably important to really provide adequate nutrition for your brain, to make sure that you're fueled, because it really does help your thinking.
Absolutely. And another fun fact for you guys is, in case you didn't know, Meera, you know, but the others, is that prefrontal cortex, it basically takes years for it to be fully developed.
That's true.
So it's not something that we are necessarily born with in terms of it's fully fleshed, that's it, it's there. It takes, I think
it's until your teens, really.
Or
18, if not later, your late teens.
18 is, according to some studies, but I think more recently they've said that it will become fully developed at around 25 years of age.
That's right, yeah. So that's why, teenagers, children aren't as in control of their impulses as adults are, because their prefrontal cortex isn't fully developed. So as tempting as it is to get annoyed with kids, you have to remember that you've got to give them a little bit of leeway sometimes, because they just don't have that inhibitory control and that mastery over their impulses that we do as adults.
Yeah, absolutely. And linking that back just for a second for children is that we also have to remember that they are born with the amygdala. They have emotions. They just don't know how to process them because of this lack of maturity of the prefrontal cortex overall. They know they feel things, but they wouldn't be able to put their finger on and say, Mom, I'm angry. They wouldn't know what that is. So yes, for
that's
the parents,
a really good point.
Parents out there, please be kind.
Yeah,
they don't know. They're tiny.
They are tiny. I've got a 3-year-old niece, so that's definitely something for me to remember next time I'm hanging out with her, because she got the hump with me last time because I told her off.
Well, nobody's perfect, but we all try our best.
We do. She knows that I love her dearly. So now, another really interesting fact, right? So you've got two halves of your brain, and interestingly, there's a bridge between the two halves that's called, really fancily, a Latin name called the corpus callosum, and it's this thick band of fibers that connects the two halves of your brain together. Now, sometimes, and rarely, when patients have epilepsy that they cannot treat any other way, they will actually snip the corpus callosum and essentially functionally separate the two halves of the brain.
Why?
And that's because it stops the seizure spreading across the whole brain.
Oh.
Yeah, so it's really for patients who like medication has just failed to control their epilepsy. And so it's interesting because it's really helped us, and these rare what they call split brain patients really helps us actually understand how the brain works. Unfortunately, we don't have time for this episode, but I'm definitely going to come back to this because I think this is just a really interesting neuroscience point, because obviously they've done different studies, and I think sometimes they've even found back in the older ones where perhaps they would have been a much more severe cutting of that corpus callosum, that they've actually found that almost the two halves of the brain are arguing with each other, and that comes out physically in like the right hand wanting to grab an object and then the left kind of fighting it.
Oh wow.
Yeah. So but now they don't necessarily dissect the whole of the corpus callosum.
Okay.
But it's a really interesting, these split brain patients is definitely one that I want to explore, but unfortunately you're going to hear enough of me talking in this episode that I'll save it for a future one.
Before we move on, sorry to interrupt you.
Not at all.
I'm curious. I might know the answer to this, but I think other people out there might think that what they read, in social media is correct. Are people left-brained or right-brained?
Oh,
because the story goes the creatives are
left-handed.
Yes, and they are left-brained, and that is, I don't know, dominant, and the more logic people are the other way, and things like that. I personally believe that can't really be true. You can't just use half of your brain. But
yeah, no, I would agree with that. I mean, like, none of the research that I read on a regular basis, subscribes to that or points that out with any sort of regularity. What's really interesting about the brain, and actually something that I was gonna a kind of joke that I was gonna crack in literally just a second, is unlike me, your brain is highly organized.
I feel listened to.
Yes. So yeah, your brain is like super organized. It has very specific areas that form very specific jobs, and I'll talk about that literally in a second and how that actually works. So yeah, there are certain parts of the brain that will dominate for certain tasks, but does that mean that you negate the other half? Not really. And also, skills that you practice like on a regular basis strengthen those areas of the brain, and that's an amazing feature of your brain called neuroplasticity, right? Where, you know, continued practice of an action, whether that's singing, playing an instrument, learning a new language, any physical skill, you start to develop more neurons or neural connections in particular in that brain. So your brain actually is pretty, what they say, plastic. So it actually molds based on the functions that you need it to perform. So actually they find with children, for example, like performing brain surgery on children actually kind of it gives them a better chance of recovery in a way, because their brains can mold according to the damage that they've sustained or what surgery they've had to undergo.
Yeah.
So it's actually pretty amazing how adaptable children actually are.
Absolutely.
In the face of, you know, really traumatic injuries.
Yeah. And the same thing comes into play when you're talking about CBT, so cognitive behavioral therapy. One of the main reasons why this is a type of therapy which is shorter term than others is because it plays on this capability of our brain to rewire in the sense of, you know, if yesterday you used to go straight to the cupboard and have 3,000 biscuits, if you're practicing a completely different behavior over time, that will not necessarily be your reality anymore, because you're building a different connection, a different path.
Yeah.
And that's the beauty of our brains, because you can do that. And if, I don't know, up until yesterday you've never written a sentence, you can start practicing it, and over time again you can write beautifully, or any other skill, as you were saying, because it literally takes mastery. You have to master that skill, whichever that is.
Yeah, absolutely. Very, very valid point. And what I find really, really fascinating about the brain, it actually kind of it links a little bit back to what we were just talking about a second ago. So just behind your frontal lobe, you've got these strips. If you imagine like two sort of ribbons that go down sort of the crown of your head, you've got what's called the primary motor cortex, and that's basically controlling all of your motor functions, so your movements. Now what's really interesting is like I mentioned that your brain is highly organized. Along this strip on each side, it basically controls the movement of from the top of your body, and it's literally like a stack of almost dominoes. So you kind of control your lips, then your neck, then your trunk, then your you know, sort of your hands, your legs, and it all just nicely comes down this strip of the primary motor cortex. Now what's really interesting is the amount of space that is dedicated to each aspect of your body is dependent on how fine the movement actually is. So that means that actually your lips, to like, you know, don't forget, you need to be able to talk, you need to be able to chew, you need to be able to swallow, all of these things.
Whistle.
Yeah, absolutely. Actually take much more space in your brain, because the detail of the movement is so fine compared to like your knee, which literally moves in one direction. So what scientists have actually done, which I just think is utterly hilarious, and I really encourage you to go and Google it if you've got time or the inclination, as one neuroscientist here does, it's called the cortical homunculus. So what they did is they actually created a physical representation of how much brain space is dedicated to that body part, and the more brain space is dedicated to the body part, the more they blew up that body part, so you could actually see in real life what it looks like. So this cortical homunculus is like the most bizarre looking person with like the biggest lips I've ever seen, which totally makes sense, right? Like, so I just think it's so interesting and absolutely fascinating. And it's one of like, for some reason, it's always been the thing, like from my studies, that's really stuck out in my mind. But yeah, if you're ever inclined, definitely worth Googling.
We're going to put the name down in the description,
yeah, I know,
guys, because it's not something you would
There's a lot
remember.
of Latin in neuroscience. Yeah, a lot of Latin. Okay, so where was I going with that story? All right, so So one of the ways that we've really begun to understand the brain is actually seeing what happens when it goes wrong, because you know, the brain is housed in this really thick skull. You need to have a patient that's awake half the time to be able to test what parts of the brain do what function. And you know, way back, they would have done far more barbaric things, and now, you know, some neurosurgery is still conducted whilst the patient is awake. Ooh. Because, you know, for example, if they're removing a tumor which is in a really delicate area, they have to make sure that they don't step in or don't put the probe into an area where that patient is going to lose a particular function.
Oh, I've seen something. I think it was a movie, and the patient was a violin.
Was this like Grey's? I bet it was Grey's Anatomy.
I can't remember, but he was playing some sort of instrument. I don't remember if it was the violin or something, but he was very, very world renowned in that particular. I
think it was Grey's.
And then in the surgery, they chose to do it while he was awake, because they were worried that he won't be able. I remember now.
Yeah.
During the surgery, he was playing the violin, because they needed to make sure that they were not touching any of the, you know, areas of the brain where he would be able to be playing.
Yeah, I mean, do you know what's funny, right? Is I actually watched, like, I want to say at least 6 solid seasons of Grey's whilst I was doing my my masters, and I convinced myself that this was educational. Like, I was like, because Derek Shepherd was a neurosurgeon, so I was like, this is educational. But what's really...
I'm sorry, but the things we say to ourselves, guys.
It's just hilarious.
Yes.
Listen, we're as fallible to this sort of stuff just as much as everyone else. So they began to really understand the brain primarily when things go wrong. So there was a really interesting patient who was named at the time in a lot of literature as Mr. Tan. So Mr. Tan had sustained some injury to his brain, and I can't remember how it was that I don't know if it was a stroke or it was a traumatic brain injury in terms of like a physical assault, but basically he lost the ability to speak. So all he could say was the syllable tan. So he could, I know, the poor guy.
I'm laughing,
so he could use hand gestures, he could, you know, vary his pitch and his inflection, so it was clear that he was trying to communicate and that he understood communications, but he literally couldn't speak. So eventually his brain was donated to science eventually, and you know, when they did an autopsy, they revealed that actually it was his left frontal area that was particularly damaged, and that ended up, and his his surgeon who discovered this was called Paul Broca, so then that became known as Broca's area, which is where we now know that speech
comes from. Yeah.
But another, arguably the most famous story I have for you, in all of neuroscience, to be honest, is the story of Phineas Gage. Have you heard this one?
No, not at all.
So Phineas Gage was around he was a guy in his sort of like early 20s, all the way back in 1848.
Ooh.
Yeah, so he was part of a crew that was creating a new railroad in America. So part of his job was to basically stuff explosives into the ground using a tamping iron rod. So if you literally imagine, you know the way they made coffee and they use the tamper thing?
Yeah.
Basically did that, but with explosives. So he had this rod, which was about 43 inches, about 1.25 inches in diameter, just to give you an idea of what this rod was like. Now, what happened was when he was stuffing the explosive with his tamping rod, it must have created sparks or something happened, and essentially the explosive detonated early.
Ugh.
Yeah. So now you know what's about to come next, guys. So essentially what happened is it pierced his left cheek, kind of went kind of through his left cheek. My left side's this side. Yeah, it's been a long day, guys. It's been a really long day. We're in the middle of a heat wave. So it's amazing I know this stuff about the brain, but I can't work out my left and right. Please leave this in. It's just, Anyway, so he went through literally like about here. He lost his left eye, unfortunately. And it literally came out of his skull about here. And then he landed about 80 feet away. Now, what was unbelievable was that he actually survived this accident.
And now I just realized that I know the story from the psychology class.
Yeah, so it comes up. It's literally the most famous, arguably one of the most famous patients. But that reminds me, we should totally do an episode on famous psychology experiments.
Yes.
That's such a good idea.
Yes, but I think we just need to do the famous ones, but not the grueling ones, because way back when you were allowed to do experiments on animals.
Yeah, it's pretty grim.
Yes, and children. So we have to be careful with that one.
Fair enough.
Yes.
So anyway, excuse me. So he, despite how severe this injury was, he actually survived, and he lost the vision in his left eye. Physically, he was okay, apart from some obviously physical scars. But what really changed was his behavior and personality. So essentially, before he was kind of seen as this God-fearing guy who had a family, he was an upstanding citizen, he was energetic, he was motivated, he was hardworking. And afterwards, he unfortunately became extremely surly, he was aggressive, and he unfortunately became an alcoholic, and he couldn't hold down a job. So really, what they noticed is it massively impaired his ability to process emotions, to make decisions, to control to have control over his impulses. So he lost his inhibitory kind of control, and particularly around social inhibition. So he just couldn't avoid reacting in certain ways or behaving or inhibiting behaviors that would be deemed as socially inappropriate. So eventually what happened was his brain and his skull in particular were donated to medical science, and they kind of worked out that he'd actually suffered injuries to his left prefrontal cortex. So those are parts of your brain that are involved in emotional processing and rational decision making. So really, he was like one of the founding patients of modern neuroscience, and led us to realize that actually different parts of the brain do different things.
Thank God for that.
Yeah, and
so not for him.
Of course,
we're very sorry for his
absolutely
history. But...
Yeah, and so he, in the end, he apparently spent time traveling around, sort of telling his story with his tamping rod, earning money. I think he eventually went and worked in stables. Unfortunately, he did die 12 years later as a result of a series of epileptic seizures. But interestingly, his skull and his tamping iron have been donated to Harvard School of Medicine, where apparently they're still exhibited today. So if you're in town around Harvard, go and have a look at Mr. Gage.
Send us a picture.
Yeah.
If you're allowed to take one, I don't know.
Yeah. Okay, so I will whittle on because there are just so many things, and actually, I think we're doing all right. We've covered quite a lot, which is brilliant. So I think I'm going to go to... Bear with me 1 second. Do you have any questions, actually, before I go on?
Well, I have a lot of questions, but God. I don't want to derail your line of thought.
My line of thought, okay.
Yeah. I'm just thinking maybe... Yeah, I'm just thinking how to best link it maybe to the limbic system and the
this limbic system was what I was going to come to. So, it's interesting because we basically categorize the brain in about 100 different ways, right? Yeah. So I've talked about left, right hemispheres. We've got the different lobes, the 4 different lobes. We've got the deeper limbic structures, which I've sort of talked about. What we can sort of very briefly discuss, I suppose, is this idea of like how the brain actually developed.
Reptilian brain.
Yeah.
Oh, that's my favorite one.
Yeah, so I actually wrote... it's interesting because I feel like now we don't tend to refer to this as much because the way that we talk about the brain has slightly, I think, evolved since then. But essentially, there was... I actually had this put in another thing that I'd read, is that your brain is like a committee of experts. They all work together, but each expert has its own special role.
Expertise.
Exactly. Its own special properties. So sometimes the brain is also divided into another 3 parts, just to add more, because why not?
Yeah.
And that's the hindbrain, which is what is called your reptilian brain, and that's kind of the upper part of the spinal cord, the brain stem, and this wrinkly bit of tissue that kind of sits at the base that you will often see. So you've got this kind of nice, almost kidney bean shaped brain. That's kind of like if you imagine the kidney with the arch at the top, and then underneath it's got this wrinkly structure, and that's called the cerebellum. Now, the hindbrain is like unbelievably important. It's the oldest of all three. It's the most primitive. But it's the most reliable, but it's also the most compulsive and rigid. So we can't change it. A lot of it is not actually even in our conscious control.
No.
So, it controls things like heart rate, your breathing, the cerebellum coordinates your movement, which, so when you're learning to play piano or you're trying to learn to hit the tennis ball as I have been, you're starting to really engage your cerebellum, and probably when you've had a bit to drink, that's why you're able to walk quite as coherently as you normally would.
Not that we endorse that, guys.
It happens to the best of us. You then got your midbrain, which is more around, your reflexes, control of eye movements, some voluntary movements, and then you've got your forebrain, and your forebrain is basically also your cerebral cortex, or what's also called the cerebrum, because why not have three different names? Because they slightly incorporate different things depending on which name you're using. But essentially, it's the largest and most highly developed, and that again, allows us, it allows us to have the seat where our memories are, to plan, imagine, think, recognize people, play games. All these different really like higher order thinking, as we say, and it's really the source of our intelligence. And that was the last bit to develop, and as I mentioned, gives us the competitive edge. Now, I mentioned really briefly the limbic system, and I think I've covered a lot of what I wanted to kind of say anyway, except let me just pivot back very quickly to the hippocampus again. So that was that seahorse shaped organ that I was talking about. Now, the hippocampus is also not only important in terms of like emotional processing, but it's actually where we generate a lot of new nerve cells that are made from adult stem cells. So it's really important, it's got a huge role in our memory. And so damage to that area can unfortunately lead to really severe memory impairments.
So just to make sure that I'm following here, we develop new cells, even brain cells.
We can. It's not as common in adulthood, and what's really important really is more than the development of new brain cells. It's also making new nerve connections, and that's the neuroplasticity element. Unfortunately, the brain is not an organ that regenerates itself, so it's not like the liver, for example, which can. So it's really, your brain is a finite resource, and it really is important to look after it as such. Now, going back really quickly to the amygdala, which is your favorite structure, it links emotions to memories.
Yes.
So it's hugely important, particularly for how memorable our memories are, because the more emotive memories are the ones that really stick. So, this is part of, as is where our fear learning comes into play, because, we can learn fears like literally within a few exposures, and sometimes even one, right? Because it's, the amygdala is also really linked to our fight or flight response, which is something that we'll continually come back to again and again and again. Now, damage to the amygdala can cause you to become more aggressive, more irritable. You lose control of your emotions, and you really struggle to actually recognize what your emotions are. So actually, scientists have linked changes to the amygdala with conditions like PTSD, bipolar disorder, autism, and depression as well. Now, I think we'll leave the hypothalamus for another conversation, which is actually one that I'm going to go to, and this is the last thing I'll talk about before we wrap this episode up, because I know I've provided you with a lot of information, but this is just to give you a kind of idea of just how amazing the brain actually is, and how much power you actually hold. So then anything that I really want you to take from this conversation is that your brain does amazing things. It's a finite resource, so you need to take care of it. It requires 20% of your energy, so it's an extremely demanding organ that needs to be fed properly in order for it to work properly. And it's not just that, but the hope is that, as Denise has kind of pointed out, and I have, it is possible to teach an old dog new tricks.
Yes.
It might take a bit longer, it may take more repetitions, but it is possible. And so
that's exactly how we learned in school. If you remember, everyone, excuse me, when we went to school, you repeated and you written the letter M 3,000 times in your little notebook until you knew how to write the letter M. And that's how we as humans predominantly learn, through repetition. Because if you've learned the lesson when you were, I don't know, 17, and then you've never ever touched it again, I'm pretty sure you don't remember it. But if you would have learned that lesson over and over and over again, you would know it now.
Yeah.
So that's very important to remember. As Meera was saying, you can always learn new things. However, what most people lack is consistency.
Yeah, it's interesting because I actually thought about mentioning the word consistency as well. Like I mean, in order, any new skill requires consistency. Meditation, for example, is the same thing. Like, you don't have to be perfect at it. And actually, I think the whole point of meditation, for example, is that it's a practice, right?
Yeah.
It's not about getting it right. It's not about being able to focus on nothing for like 30 minutes or however long you do it. It's actually the practice of pulling yourself back to the present moment when you're starting to get lost in your thoughts.
Absolutely. And there are so many skills like that. So even going to therapy is one of these skills, because the first time you are chatting to somebody, be it a coach, a hypnotherapist, a nutritionist, the first conversation might be uncomfortable because you don't really know what you're supposed to be, expecting. How is it going to work out? But then if you stick to it for however long you need to stick to it, you're like, oh, this is actually helping. This is actually helping me develop.
And what's really interesting about therapy, like, I had this conversation recently, and I've read a few books, particularly on the type of therapy that I've had. And, I think through the process of going and then helping you to kind of see a different perspective, or learn how to step out of the situation and analyze it for what it is, rather than what your emotional side is telling you that it is.
Yep.
You actually learn to internalize your therapist's voice, and that's how you know when you're healing.
Yes.
And that is something. So basically, instead of like having an emotional reaction to a situation, so say like, I don't know, your boss has has just said, hey, this isn't right. You're automatically potentially feeling really criticized, and you overreact in a situation, or you take it really badly. What I think therapy allows you to do, because of the practice, because of the consistency in them reframing your thoughts, is actually you learn, what would X tell me that I should be thinking, or not I should be, what would X say in this situation?
Absolutely.
And that learning, that internalization, it's a skill. It's a skill.
It's a skill. And if I might add, that's the reason why most therapists are therapists, in the sense of, especially for me, is like, I am not interested in being the therapist for somebody for a very long period of time, also because of the conditions and issues I deal with.
Yeah.
But what I want everybody to who walks through my virtual door to be able to do is to become their own therapist. So I'll provide the information, the psychoeducation, as you say, linking that part of, the emotion with something that the shoulds, the musts, the have-tos that may not be correct for them. And then at some point, as you say, they are healing, they are to the point of actually, I can do this by myself.
Yeah.
I know how to be my own therapist.
Yeah.
I don't need to be going back for more, if that makes sense.
Yeah.
I'm using quotation marks here because, again, I don't want to generalize, but that's what I intend to do with people in my practice, and I'm sure you do the same with your clients in nutrition, is you want them to be at the stage where they are, I got this. I know if I have new challenges tomorrow, I know how to deal with them.
Yeah, totally. Like, I think like any professional, like you are there to provide the tools and as you say, the educational piece. You definitely can't walk the walk for your clients in any way, shape or form. And it's up to them to take that on board and really use that. And that's how you get the most out of any type of these, I think allied therapies or talking therapy or whatever it is. But I think that point of learning is just so interesting in the way that actually, that you learn. It's a skill that you learn, but it requires that consistency.
Yeah, you have to stick at it. You have to have the system in place to set yourself up for success.
Absolutely. Yeah.
If I'm linking it back to our previous conversation with Andrea, if you haven't listened to it, guys, it's we've had an episode with Andrea, who's a personal trainer and a coach as well, and she was saying you don't always have motivation on hand because motivation can be quite futile sometimes. And let's let's be honest, we all know procrastination.
Oh, yes.
Sometimes she's our best friend. And in these situations where you are like, oh, I'm not really motivated to do it, the system in place, the consistency, the discipline will get you there.
Totally, yeah. And, and I think, this is going to sound so trite, but like also, no one's perfect. Consistency doesn't mean every single day without fail. Ideally, for some things it is, and especially for a period of time it might be. But then eventually you'll get to a point where you've learned the skill well enough that even if you go without it for a day, it's not the end of the world.
Absolutely. And maybe we'll link back to this in the next episode. But if you can remember when you first started doing your driving lessons, right? You were completely not sure of what you were doing, how you're supposed to drive, whatever. But once you got to the point, it's what we call the unconscious consciousness. You have moments when you drive yourself from work to home and you have no idea how you got there, but you got there safely, and that is because you are unconsciously conscious. And that's, again, it's a skill. You mastered it over time, and then you become so good at it that you don't need to, think about it on purpose. Now I turn left and I indicate and I move my hand on the wheel. You don't have to do that. It's the same with once you get new skills in therapy or coaching, for example. You have I know what to do now. I don't have to repeat it. One last thing I'm going to say on this one, guys, is when you were children, you must all remember when you were learning how to tie your shoelaces. And at the beginning, your mom, your parent, your carer, whoever that was telling you how to tie the shoelaces. And if you may remember, you were telling it to yourself. You were saying, now the left goes over the right, and now I make a little bow. And you were telling yourself what you are doing. And that's probably how you learn to do many other things when you were playing and so on. It's exactly like that to this day.
Oh, yeah.
We tell ourselves what we are doing until we get to that point where we don't need to anymore.
Yeah, you've just internalized it and you can do it almost unconsciously.
Yes.
Yeah, but it takes time and practice. But the point is, your brain can do it. So whether you're learning from Denise or whether it's from me or hopefully the both of us, it's still totally within your control.
Absolutely. It always is. No matter what you read on social media, it's always in your control, guys.
Yeah, 100%. There's way more that I could say.
Gosh. She has a full notebook.
I do. It's packed. But that's kind of a whistle-stop tour of all the different parts of your brain. So I think for future episodes, I'm going to pivot towards more nutrition. I'll come back to these structures. I'll come back with more interesting facts and perhaps different other famous neuroscience patients. But guys, for now, that's this episode wrapped up. So thank you so much for listening. I hope you've enjoyed our professional setup as much as we have. I've loved it. Give us, if you're watching us on YouTube, if you're on Spotify or wherever you get your podcasts, please give us a like, give us a rating, subscribe, follow, do all the things. It helps us get more noticed. It helps us gather more listeners. And please, feel free to provide us with feedback. We'll put all our socials out there and all our contact details. And you can always get in touch with us if you have any questions.
Absolutely. We welcome the questions and we welcome also the criticism.
100%.
As long as it's constructive criticism, that would be absolutely well received.
Yeah.
Yes.
So anything you want to know about, anything you want to hear more about, just let us know. We plan to do this for a while, so we've got time. We have time.
Absolutely, and there will be a test.
But we'll wrap that up. Thanks so much, Denise, for listening, and thank you everyone, and we'll speak to you soon.
Take care.
Bye.